Our dear viewers, you most welcome to this channel which we call the Cover Math. Those that have subscribed, thank you very much. Please tell a friend, we need more subscribers. Today, we want to look at trigonometry for the case of A-level mathematics. A-level mathematics, paper 1. Today, I introduce to you trigonometry. Now, under trigonometry, we are going to be looking at the relationship between angles of a triangle and its sides. So we're going to look at the relationship between angles of a triangle and its sides. Remember, triangle has 3 sides. So today we want to look at the relationship. Between the triangle and its sides. If this is theta, if this is alpha, if this is beta. So these sides and angles are related using 3 basic ratios. Those ratios include, we have what we call sine, that's the first basic ratio. We have what we call the cosine, and then we shall have what we call the tangent. So these are the 3 basic ratios. But now, in HSC, we are going to add on more 3. We're going to add on more 3. The first one will be the secant, which is 1 out of the cosine. So whenever we say secant, it is 1 out of the cosine. Then we shall have what we call the cosecant. The cosecant will be 1 out of the sine. Then lastly, we shall have the cotangent. The cotangent, which will be 1 out of the tangent. So whenever we say cotangent, it is 1 out of the tangent. Cosecant is 1 out of the sine. Secant is 1 out of the cosine. Now, these ratios are related. They are related, and maybe what we should still know is that tan theta is the same as sine theta out of the cosine of theta. We are going to see how this one comes about. Now, we are going to first of all consider a right-angled triangle. A right-angled triangle. Now, whenever we have a right-angled triangle, remember, a right-angled triangle has one of its interior angles as 90 degrees. So if I have A, I have this point as B, I have this point as C. This one is what we call the hypotenuse. This is what we call the hypotenuse. And whenever we have a right-angled triangle, we can bring in what we call Pythagoras theorem, which says that AB squared plus BC squared will give us AC squared. So this is what we call Pythagoras theorem. Now, whenever we have a right-angled triangle, of course this is always the hypotenuse, we may have another interior angle. Theta. So let theta be here. Now when theta is here, we should know that this side here, where the angle is facing, this side, this one becomes the opposite side of the angle. Then where the angle is sitting is always going to become our adjacent. So we're going to use opposite, O for the opposite, then we're going to use A for the adjacent, and then we're going to use capital H for the hypotenuse. That's where we derive SOHCAHTOA. What does SOHCAHTOA mean? SOHCAHTOA means the side of an angle is the opposite out of the hypotenuse. The cosine of an angle is the adjacent out of the hypotenuse. The tan of an angle is the opposite out of the adjacent. So meaning that SOHCAHTOA can only be used if we have a right-angled triangle. So in this case, our angle theta is here. It means this becomes our adjacent, this becomes our opposite, this becomes our hypotenuse. I can now say sine of the angle theta is that the opposite, which is AB, out of the hypotenuse, which is AC. The cosine of the angle theta will be the adjacent, which is BC, out of the hypotenuse, which is AC. Then we can also have that tan of the angle theta will be the opposite, which is AB, out of the adjacent BC. Now, we want to first of all show that the tan theta is the sine theta out of the cos of theta. So what is sine theta out of cos theta? Sine theta out of cos theta. Sine theta out of cos theta. Sine theta is AB out of AC. AB divided by AC. Divided by cos theta. What is cos theta? This will be BC out of AC. So this one will give us AB out of AC times AC out of BC. AC cancels all this, will remain with AB out of BC. But do you have AB out of BC? Yes. AB out of BC was tan theta. Hence, whenever we have sine theta out of cos theta, it is as simple as saying that this one is the tan of theta. So this is the first proof. Now, from here, still using Pythagoras' theorem, we want to derive the three basic identities. We have to derive the three basic identities. We said by Pythagoras' theorem, AB squared plus BC squared is AC squared. We can decide to divide by AC squared both everywhere. So divide by AC squared by AC squared by AC squared. We had our equation here, then we divide it everywhere by A squared, by AC squared, by AC squared, by AC squared. So it means we shall have AB squared out of AC squared plus BC squared out of AC squared is equal to 1, because AC squared divided by AC squared is 1. So, what is AB out of AC? Remember, AB and AC are squared, meaning that it's the same as AB out of AC squared. What is AB out of AC? AB out of AC is sine of theta, meaning that this one squared will be sine squared theta. So this will be sine of the theta squared. So this is sine squared theta. So we are replacing this with sine theta. Why? AB out of AC will be sine theta. Then what is BC out of AC? BC out of AC is cos theta, meaning that this will be a plus cos squared theta is equal to 1. This is the first identity that we should know, that sine squared theta plus cos squared theta should always give us 1. So long as the angle is the same, then the sine squared plus the cos squared of that angle should always give us 1. This becomes our first basic equation. We can use this other equation to get other identities. How? From 1, we are going to divide through by sine squared theta. So that means we shall have sine squared theta plus cos squared theta is equal to 1, divided by sine squared theta divided by sine squared theta divided by sine squared theta. Sine squared divided by sine squared is 1 plus cos out of sine. We said the tan theta is sine theta out of cos theta, meaning that cos theta out of sine theta will be 1 out of tan theta. But what is 1 out of tan theta? 1 out of tan theta, we said it is cot theta. So meaning that this will be cot, but this is squared, so we shall have cot squared theta is equal to 1 out of the sine squared. 1 out of the sine, we said 1 out of the sine is the cosec, meaning that this will be a cosec squared theta. So this will be the second identity. Second identity will be 1 plus cot squared theta is equal to cosec squared theta. Maybe lastly, you can say from 1, we want to divide, from this equation 1, we want to divide by cos squared theta everywhere. So we shall write sine squared theta plus cos squared theta is equal to 1 divided by cos squared theta divided by cos squared theta divided by cos squared theta. Sine out of cos. What is sine out of cos? Tan. Meaning that sine squared out of cos squared will be tan squared theta plus cos squared divided by cos squared theta will be 1 is equal to 1 out of the cos squared. What is 1 out of the cosine? 1 out of the cosine is the secant. So meaning that this will be sec squared theta. So this will be another identity that we should always remember. That tan squared theta plus 1 is the same as sec squared theta. Where we said sec is 1 out of the cosine, cosec is 1 out of the sine, cot is 1 out of the tan, or the cosine out of the sine. In the next episode, we shall look at how to use these three identities. The first one here, another one here, another one here. Thank you for watching, and please continue to subscribe to this YouTube channel. Thank you very much for watching.